All right, good morning, good afternoon, or maybe good evening, depending on where you're listening from. Also, depending on when you listen to us, as a reminder, this call is being recorded and will be available on demand. You can access the recording through the event registration page soon after our call is over, and we will also make it available together with the deck on your Yammer community group. So yeah, welcome and thank you for joining us. I'm Sarah Van Hambrum, a partner technical evangelist here at Microsoft and also your OSS community lead for this year. Now for the fun stuff. Today we're going to talk SQL on Linux. To do that, I have with me Bob Ward, who's a principal architect on the team. Bob, feel free to introduce yourself and take it away.
Thanks a lot, Sarah. Yes. I'm Bob Ward. I am an architect on the SQL engineering team. Let me go ahead and share out my desktop here so you can see my slide deck, and we have a couple of demos we're going to go over as well. So, Sarah, let me do this first, and you make sure you can tell me you can see this okay. Let's see. Here we go. So while that's pulling up, there we go. Great, thank you. Yeah, so I'm an architect with the SQL engineering team, and it's really ironic that I'm talking today about SQL Server and Linux and Docker containers. This is my 25th year at Microsoft working on SQL Server, all the way back to SQL Server OS 2.1. And before I joined the company, I worked on Linux. I was a Unix developer on Oracle and C++ systems way back in the late 80s, early 90s. And joined Microsoft and became, of course, a heavy Windows user and an expert on learning the internals of Windows working with SQL Server. And again, that's the irony that I never thought in my career we would see SQL Server and be talking about it running on Linux. So it's my pleasure to come to you guys today about this. I'm a big believer in people getting access to anything I present, deck or demo-wise. And you see here on the screen a couple of locations, aka.ms/bobwardms. This actual presentation is available for you there to pull down. You could even pull it down while we're talking right now. And also, I have a GitHub repo where I put a lot of my demonstrations and demos, and you can certainly just look for GitHub Bob SQL, and you'll find all those demos. And I love talking about this product, and especially talking about SQL Server on Linux. So if you've got a question that we don't answer today or don't have time to answer, or you think about it at another point in time, and it's really important for you to work with your customers, feel free to send me an email at bobward@microsoft.com. Let's get into this stuff. Let's talk about the technology. This deck is actually meant for a presentation that's a little longer than an hour, so I'm going to skip a few slides, but again, you'll have access to the entire slide deck. Before I go into the details of SQL Server on Linux, I think it's important for you to understand the value proposition of SQL Server 2017 itself. Like, what's different about this release from previous versions of SQL Server? And this slide, for me, kind of summarizes areas of the product that we've enhanced from what we've done on SQL 16. And SQL 16 was a great release, and we made a lot of great enhancements there, including things like always encrypted and query store, new and rich features for customers, a lot of performance enhancements. And so we built upon that to build SQL 17. But of course, SQL 16 only ran on Windows. So you see in the upper left-hand corner here, we've now built SQL Server to run on a platform of your choice. I often have customers ask me, why did you do this? Or, do you not care about Windows anymore, SQL team? And the answer is actually the best answer I gave at a customer event when someone said, Bob, should I run SQL Server on Windows or Linux? And my answer was yes. And I was being tongue-in-cheek. My point is, in the SQL Server engineering team, we want you to just run SQL Server. And we built SQL Server to run on Linux for a very good reason. That is, we wanted any customer out there not to have a reason to not run SQL Server. We've run into issues and situations in customer shops where they had Windows and they had Linux in their environment, and they would love to go to SQL Server as a database platform in their environment, but they couldn't do it on the Linux systems. So that's really the primary driver of this entire project is that we wanted customers to have a platform of choice, but we think SQL Server runs really well on all these platforms. Whether it's a Linux distribution, it's still Windows Server for you, or even in Docker containers. If you look at the middle of the upper section here of this chart, and in the top right-hand corner, there are two performance enhancements that we've done in SQL 17. One's called adaptive query processing, and one's called automatic tuning. And we kind of refer to these as intelligent database features. And what I mean by that is that these aren't just features to make SQL Server run fast for your application. They're features to help keep you fast. So you might go build an application and get it run really well with SQL, and then all of a sudden, over time, you have query performance problems. So these features are designed to aid you in those scenarios. And because the SQL Server core engine is the same code running on Linux and Windows, and we're going to show you why that is in our architecture discussion, These features light up in both versions of SQL Server, no matter what platform you're running on. So adaptive query processing is all about built-in functionality to the query processor engine itself to detect a query performance problem after you run a query, and then adapt itself to what's cached in memory, the plan cached in memory, and then make changes to make your query run faster the next time. Automatic tuning is a feature that actually uses the telemetry of the rich feature called Query Store, which we introduced, I said, in SQL 16. It uses that telemetry to make decisions to revert back to a query plan that was previously running well for you. You have potentially unexpected scenarios in your environment where a plan may regress to something that doesn't perform as well, and we can detect that with Query Store. We can either give you recommendations on how to resolve it yourself, or if you turn on a switch for a database option, we can then resolve the problem for you automatically. So those are some intelligent performance enhancements we've made in SQL 17. At the bottom left-hand corner, availability group being our flagship product, we have a feature called clusterless availability groups. I'm going to talk about that in more detail in the talk today. And I told you I've been in SQL Server for 25 years, and I've seen this relational database engine become an amazing platform for many people. But today we kind of like to refer to it as a modern data platform. And the reason why is we've extended SQL Server to not just be about tables and columns and rows. Look at the middle of the bottom part of this chart here. You'll see we have something called graph data types. Now, we're not going to drill into that because that particular feature is on SQL 17 in general. It's not specific to Linux, but I want to make sure you're aware that we now support graph data types. And in the bottom right-hand corner, we talk about machine learning. We've now, starting with SQL 16 and now piled on with SQL 17, have the capabilities of running machine learning algorithms co-located with the SQL Server data in a high-performant way, and introducing a new feature called native scoring that allows you to bring your machine learning models and run SQL Server models inside the engine in new T-SQL extensions. One of the things we're a big believer in is consistency. So you can run SQL Server 2017 in Azure, in a cloud, in whatever cloud environment you like, in a virtual machine environment, or you can run it on your own private cloud scenario. And the T-SQL language is a consistency where you see these things like graph data or machine learning or something. We always extend the T-SQL language so that your investment in those skills last. And it still applies to customers running SQL Server on Linux. So if you think about what we've done and given platform of choice to customers, we made a very conscious decision because there's lots of distributions out there, Linux distributions for customers. We chose 3 to officially support out of the gate because we wanted to give customers a world-class experience that is well-tested, and we developed partnerships with Red Hat, SUSE, and Ubuntu to make sure even your support experience is integrated. So if you contact Microsoft support, you don't get just shoved around to another vendor or another partner. We work closely together, our support teams, to solve customer issues. So we have contracts with these vendors that we've worked with to make that happen, and then we work closely with them to make sure our SQL Server product runs really well on their distribution. And then again, we support also Docker containers. We're going to talk a lot more about that later in the talk. And then we have the basic memory system requirements for running SQL Server on Linux. Now, one of the questions I get a lot when I talk about SQL Server on Linux is it the same? Is it the same feature set of SQL Server on Windows as you did on Linux in 2017? And the answer for the most part is yes, because again, the core database engine, the code is unchanged between them. So if you look kind of the middle of this table, a lot of features you may see about OLTP or analytics, things like column store, our own query processing engine, availability groups, and so forth, they all run the same on both systems. Now, in some cases, you might have some configuration differences because, for example, availability groups to use clustering is going to need to rely on particular packages that go with Linux versus Windows, but the functionality is the same. But you see in the diagram there are a few areas where the functionality is not the same. So, for example, our BI services, like analysis services or reporting services, those services were not ported to work on the SQL Server Linux platform or made to move in SQL Server Linux. That's something those teams are looking at, but out of the gate in 17, those don't exist. And at the bottom, there's a few other type of features, maybe like a polybase or stretch database, file table, and so forth. Some of those features don't exist. There are a few feature gaps that are important to customers that we are working on to ensure we shore those up. And if you look at a table like this, or you look closely at SQL Server on Linux and Windows, and you find features that don't exist, you need to let us know. Send us an email, and we'll take and talk to you and your customers about how important that is. One thing that may not stand out to you, though, that does exist that's outside the core engine is SSIS and SQL Agent both work on the SQL Server Linux platform as they do on Windows. This slide is a little bit more of a detailed version that I put together to kind of give my perspective to you about, is this really the same? For example, the deployment experience is going to be different. We're going to show you a nice little demo what that actually looks like. We rely on something called the SQL PAL architecture on Linux to make things run in a new and exciting way without having to port all our code. We're going to talk about that. You get to log into SQL just like you do on Windows with SQL authentication, and we support Active Directory integration as well. We'll talk about clustering a little bit, how we use a package called Pacemaker to give equivalent functionality as you would have with Windows failover clustering. And then we wanted to make sure that SQL Server out of the gate runs really well on Linux as it does on Windows. And we're going to talk a little bit about performance. But we talked to some of our Linux experts, both from our partners and with our team, and we've got some performance best practice guidance for specific kernel settings within Linux to give you optimal performance. They may be things that you don't need to do, but if you're looking for like the best optimal scenario to run Linux, say on a bare metal server, you would go look at these kernel settings and apply them. Some Windows configuration options that used to exist, like lock pages in memory, instant file initialization, those kind of things don't even exist on the Linux operating system. Those are very Windows dependent, and so you don't have to even worry about those. In some cases, the behavior like instant file initialization is the behavior of the Linux kernel, so things run equivalent without you doing any kind of changes. These are two features that do show up that some customers have asked me about, and that is distributed transactions and SQL Server replication. Those don't work today on SQL Server on Linux as they do on Windows, but we'd love to have customer feedback on how important that is as a blocking scenario for you on whether you need that to work in your environment. But we are working on that. That's something we're kind of looking at for the future of what we'll do. Another question I get is multi-instance support. We do not support installing SQL Server multiple instances on a given Linux server or inside a VM, but we have the concept of Docker containers for that reason, and we'll talk about that when we give you examples about how to run Docker containers. And the final question I get is, do you need to know Linux? If you're a SQL Server on Windows person and I want to run a SQL Server on Linux, do I have to be a Linux guru? And my answer would be is that it all depends on what kind of level of knowledge that you're looking for as you had on Windows. Like what level of knowledge on Windows today do you have to run SQL Server? If you've got a pretty deep knowledge and that's required to run SQL Server on Windows, you probably will have to have some knowledge on Linux to make it run really well. I will tell you that once you go through the deployment experience and install it and get it to run and start connecting with it, there's not a deep knowledge required just to get your application up and running and testing and working on SQL on Linux. It's going to be more your comfortableness of really diving in to see, do I have it tuned right and optimized for my Linux environment? Or am I configuring a cluster or an availability group or special security for encrypting connections? That's where you'll start diving into you need to learn how to use a Linux shell and some of the commands that go with that. So Linux loves packages, and the deployment experience is what's called a package management experience. And we've embraced the natural package managed softwares from those environments. So in Windows, you're using Windows Installer, which is a common platform for installing Windows software like SQL Server. And in Linux, it's all about packages. So each of them have their own package management commands. It's all very command-driven. And we embrace that. So you're going to see an example and a demo of how we do that. And really what happens, it's a very lightweight experience. And we've chosen to actually put these packages, as you'll see, you can connect it on the internet and pull them down in a way that's very contained. So like the SQL Server package contains SQL Server and SQL Agent. That's all it contains. But if you wanted to run the tools, it's a separate package like SQL Command or full text search or high availability or even SSIS. Those are separate packages. And that allows us to give that more lightweight experience. Plus, we kind of believe in doing a deploy config post-deploy experience. So you're going to see here in a second, you're going to install SQL Server, and then the configuration things you're going to do are kind of after you do the installation itself. But this package software gives you a lot of advantages. It has built-in dependency checks, pulls down all the necessary dependent packages if that's necessary, and so you get versioning. You get a very easy experience to do updates, rollbacks, removes, uninstalls, some of those kind of type things. And in fact, what you also get in the true spirit of Linux is a bash script and a set of Python scripts. So when you install SQL Server, you're going to configure it after you install it. And when you want to do things you're used to doing in SQL Server Configuration Manager, which is a Windows GUI application, you're going to use this MS SQL comp script to maybe enable SQL Agent or set up the default database directory or something of that nature. So there's a set of options that run with this bash script to allow you to do these configuration settings. And these are all settings that you would do to configure SQL Server outside the normal SQL Server configuration commands like spconfigure or alter server configuration. Those commands run unchanged because the core server engine is the same. But if you need to do configuration outside the T-SQL interfaces, you would use this MS SQL comp script. We'll show you an example of that. And then, as I mentioned about using these package management systems, there's an offline process to do because a lot of people, the standard deployment experience actually connects to the internet and pulls packages down to install them. You may be in a scenario where your machine is not connected to the internet or maybe sparsely connected. And so there is an offline experience for you to pull the package down somewhere else, copy it to the Linux machine, and then run the installation experience. You can do things that are unattended. You can do simple updates, rollbacks, and uninstalls very easy. I do want to stop right here and make sure you know of one thing. You might be aware, if you've used SQL Server in the past, of this concept called service packs. Well, starting for SQL 2017, we are no longer doing service packs. So we only do cumulative updates on a monthly type basis. And as the major release ages, those updates will start becoming in a less frequent fashion. Now, previous versions of SQL still offer the service pack train and that update policy like SQL 16. But starting with SQL 17, both on Windows and Linux, we will no longer do service packs. So let's talk a little bit about the architecture, and then we'll stop, get some questions in, and then do a demo. We had this choice when we were actually building SQL Server on Linux a couple of years ago, and that is we kind of looked at the product and said, okay, how do we port all of our code? How do we recompile all the SQL Server code running on Windows today, compile it for Linux, and then make all the changes we need to make to interact with the Linux operating system like we do the Windows operating system? Well, if we had made that choice to make a native port of SQL Server on Linux, we would not be having this conversation today. We'd be talking maybe about the project still or something, right? We call it Project Helsinki. So we'd still be talking about Helsinki. We wouldn't be talking about SQL out there in production environments. So along comes in 2011 this project called Microsoft, a research project called Drawbridge. And so we looked at that project, and the project was this. It was kind of back before the container world became popular. It was actually after modeling a scenario that kind of looked like a container. And the idea was, could you take a Windows application, and without it changing at all, could you build components of software that would implement Windows API calls in user mode? Without them going to the actual kernel itself to switch to a kernel context, could you actually do that from many, many different APIs required by the application? And then only in the cases that really required a kernel service, like maybe I/O or memory or thread scheduling, that's when you would actually make this transition to go to the actual kernel itself. And so they built this concept called a platform abstraction layer in the form of some DLLs. So the app would remain unchanged, but when it made these Windows calls, the platform abstraction layer would make this decision: can I implement the API in user mode in a lightweight way, or can I go to the kernel? And in some cases, they determined that an application, there were some Windows API calls that they didn't need at all. So they just kind of stubbed those out. So what was built now was a much lighter process in Windows for this application to run that didn't have to go to the kernel as much. And then the app itself could become abstracted actually from the underlying operating system. So we took that concept. And if you look at this diagram right here, this is how we use that drawbridge concept. We've built something called the SQL platform abstraction layer. And these blue boxes represent that. In some cases, what we call LibOS is an implementation of Windows APIs that don't have to go to, say, a kernel. And then in some cases, there are APIs that have to go down to the kernel layer. But this is Linux. This isn't Windows. So how do we do that? Well, this code right here in this black box called host extension is natively compiled for Linux and has all the necessary calls to go to the Linux kernel for I/O memory, CPU scheduling, threads, etc. And what happens is the SQL PAL makes a decision. Either it can implement in user mode this code to run Windows APIs, or it can transition and pass on to this host extension the necessary information to let it call the Linux kernel for these services. And this code is very lightweight, and it's very small. And the transition is done through something called an ABI. It's a very clever set of assembly instructions that allow us to run SQL Server, SQL PAL, and SQL Agent compiled on Windows, literally, but run it in this environment in a Linux process where it doesn't even really know it's running on Linux, but make this transition to this host extension because it's all Intel-based architecture. This is all assembly code running Intel-based architectures. So over here on this left-hand angle, everything here is the actual Linux process called SQL Server, but in the red box, that is actually binary code that we've packaged that we compile on SQL Server for Windows that just runs in this Linux environment. And so you can see now what we've been able to achieve. The SQL Server core engine doesn't have to be changed any. And that's why in the gray box for agent and SQL Server, it is the same binary code that runs. And we have a way of loading it into the process space of a Linux SQL Server process and running it unchanged. Now, on the bottom right-hand corner here, you see something called a parent watchdog process. So when you start SQL Server, there are actually two SQL Server executables running, two binaries. One is this parent process that actually forks off the main SQL Server database engine. And one of the nice things that this allows us to do is this parent process can kind of monitor the behavior of the SQL Server engine, the other process, the child process, and that there are problems like a core dump. It can be part of the program involved to actually make sure the core dump is captured with all the diagnostics for any troubleshooting purposes that have to be done. So that's really the architecture. It's pretty amazing. Now, we built this so that customers don't have to understand this architecture. But we always try to talk about it because customers ask us, how are you doing this? And how did you build this in a way that so quickly when you announce SQL Server on Linux, and in a way that allows you to make sure SQL Server doesn't have two code paths. So when you make a change or enhancement to column store, you don't have to make it in two places. You just make it in one place, and it runs unchanged. And we're going to talk about, after the demo, how we're able to achieve performance in this environment equivalent to what we've seen on Windows. And so the SQL Server core engine, of course, is the same, but with these transition layers, they're so lightweight that we're able to achieve the performance that we need for database applications, just like we have on Windows. Let's stop, Sarah. A lot of stuff I just threw at you, right, in your audience. Let's stop and see if we have any interesting questions.
So not in the moment, but let me tell you, our audience sometimes can be camera shy because this is being recorded. So let's give them a little.
Sure, no problem. It's a lot of stuff, right? And it's an amazing project that we've built. And remember, we've built this in a way that we want applications to run unchanged. For example, you can take a database backup on Windows and you can restore it on SQL on Linux because the core engine is the same core code. Your application that's a Node.js application, maybe you've built one to connect with the tedious driver to SQL Server on Windows. It can connect and run to SQL Server on Linux virtually unchanged. So that's really our goal we had to make sure application developers don't have to make a lot of changes to move this environment. Maybe you have one of those feature things like replication that may cause some changes for you, but we really believe that applications can run unchanged if they were running first to SQL Server on Windows. Okay, Sarah, let me, maybe while the audience is thinking about some questions, let me flip over and do a little demo. How's that sound?
That sounds perfect.
Okay. So I'm running on a Windows 10 laptop here, and I've got Hyper-V running. So I've got a virtual machine running Red Hat Enterprise Linux. And this is a tool I love to use called MOBA Xterm, right down here. MOBA Xterm is the name of it. It's a free download. So if you're a Windows user on the phone right now, you're used to using a remote desktop. But if you're a Linux user on the phone, you're like, I don't use that stuff. I use a secured shell program. And you may have your PuTTY. Windows 10 even comes with its own bash shell. Mac users out there have a built-in shell already into Mac. So you're used to use something called a SSH or secured shell. This is MOBA Xterm secured shell. I love this interface because the thing I love about it the most is I can copy and paste into this window here. But let me show you the deployment experience. So it's this simple. I can run sudo, which is if you're a Linux person, this is super user a command. I'm going to run as the root user a command. I'm going to run something called yum, which is the name of the package manager for Red Hat. Install. -y means I don't want any prompts, and I'm going to say MS SQL Server. And what's going to happen here after I put in the root password is that it's going to go to the internet and pull down the latest SQL Server package based on the latest cumulative update, and it's going to install this on my machine. And again, remember our goal here is we wanted to make this very lightweight and fast. So what you see right now is it's just downloading the package from the internet. And again, there's an offline experience if you need to do that. And then it's going to go through the install process. And the install process is really easy. It's just like take the binary package, extract it out, put in the right directory structures for our binaries and your data and log directories, create a user called MS SQL, which is kind of like your SQL Service SID kind of idea, like an MS SQL local Linux account. That's going to own the binaries and the directories for SQL Server, and it's going to own the service. And then Linux has a service concept like Windows does called systemd, and so we're going to register ourselves as a systemd service. And that's really what all we're doing here. Now, if you see here the SQL Server version that's running right here, that is the latest CU5 version. So anytime you just do a standard install, we just go get the latest. And so people are used to, in the Windows world, applying SQL Server, then applying patches. Well, we've kind of slipstreamed it. So anytime you just want the latest version and you install a new version of SQL Linux, we give you the latest. But then you have choices if you want to go to a specific version. So that is the basic deployment step. Now it instructs me to run this command, which is that MS SQL comp script. So let me paste that in the window here. Now this is where you're going to make some choices. Now, one thing you should know, you're probably asking if you're a very command-driven type person, is you can set up environment variables here to automate this portion as well. Lets you do the complete unattended experience, right? But I'm going to answer through them. So this is where you pick your edition. I'm going to pick Enterprise Core here, so I'll pick 7. I'm going to agree to the EULA, and then I'm going to put in my SA password. Type this carefully so I don't mess this up. So what this is going to do is actually start SQL Server, run a command to actually burn in the PID, the actual Enterprise Edition. So it's a valid Enterprise Edition. Install the SA password, and it's done. I know you don't believe this, but that's the installation experience. That's all you do to run SQL Server. And let me just prove it to you. This is a command to look at the status of the SQL Server service. There you go. And right here is those two process IDs I was telling you about. This is the parent watchdog process I mentioned, and this is that child watchdog child process. This is the true SQL Server process. And so most SQL Server users, the first thing they want to do is look at the error log. So we have that. So I'll run the cat command to go var opt ms SQL log. This is where the error log is, and there's your error log. And maybe you want to connect to SQL Server, right? That makes sense. In fact, what I'll do is I'll actually restore a database. I've got in here the wide world importer sample right here that I pulled over and downloaded, which again, this is a database that could be stored on Windows or on Linux. I think the first thing I'll do is I'm going to add a login. So I'm going to add a login other than SA, so I'll just interact with that login. And this is just a shell script I've written to do that. You will have all these in the demo directory at my GitHub when you look at that. Then I'm going to go copy over that backup from my home directory into the normal directories for SQL Server. And then I'm going to do a restore. And this is a shell script that's simply going to run SQL command. This is the password for the new login. So what's going to do is going to run SQL command, which we have a native version of SQL command, to restore the wide world importer's backup on this machine. And this is a 2016 backup, so it's going to have to do some upgrade steps to do the restore. But this is as simple as it gets to take a database backup and just restore it and start playing with it. So once this finishes, while this finishes, I'm going to flip over and show you our new cross-platform GUI tool. This is called SQL Operations Studio, and if you've not seen this before, it's pretty cool. So you may be sitting on the phone right now going, I'm a Mac user, I got a bunch of Mac users out there, I don't even like Windows. That's fine. We're okay with that because SQL Operations Studio is open source and runs on Windows, Mac, and Linux with this same look and feel. So I'm going to try to connect in to that actual SQL Server on Linux. And look at this. I can actually scroll in and look at the database that I just did. And I'll just run a query here. So I get to run standard queries. Select star from, I'll look at the sales schema, I think here. I think I know that schema. And I've got IntelliSense built in just like I do in Management Studio, a tool like that. So I'll get here. I'll actually run it. And I'll come back. And I got a query running just like I would run this against SQL Server on Windows. Management Studio, that's a tool that we support on Windows platforms. That works just unchanged against the SQL Server on Linux. And then we have a new tool called MS SQL CLI, a new command line one. Let me show you that. So here's MS SQL CLI, which is also cross-platform and open source. Let me see here. Yeah. Host. Oops. Oh, here we go. We put in this case, I'll just connect as SA. This is actually based on Python. And so now I also have the IntelliSense built in it as well. So I could say like use wide world, so it recognizes my database, the wide world importer's database, and I could start running queries from there. So MS SQL CLI runs on Linux, Mac, and Windows as well. It's the new open source cross-platform command line tool. So that's just a quick little demo on how to get up and starting on SQL Linux. A lot of people know a lot of incredible shell commands and they're shell masters. If you're not, one program I love to do just for performance monitoring is HTOP. It allows me to take a look at overall CPU performance by processor, and then also process utilization and memory utilization for like the SQL Server process. So that's the quick demo on SQL Linux. That's how fast it is to deploy this and connect and start using it. Use any base tool that you like, that you prefer. We've got them now across platform for you to connect and run your programs, your queries, and your application. Sarah, anybody ventured for a question at this point?
So not necessarily a question, but we did get a couple of folks that are very impressed by the experience.
Nice. That's awesome. That's great. That's actually why we built it. We wanted to make sure people, and people just don't believe me when I do this. They're like, that's not really working. So I have to kind of actually connect to a SQL and show them that it actually really works.
We did have a question regarding the last tool that you mentioned that they could use to visualize the performance, and I believe it was called HTOP.
Yes, HTOP.
Thank you. That's it for now.
Yeah, HTOP is a popular package that you can install on most Linux distributions. There's some built into some of these, and you're going to find yourself, if you're not a Linux user, there's a ton of these commands that are their favorite commands for everyone. HTOP's what I just love because it has a little more of a graphical feel, even though it's in the shell itself. So out of the gate, one of the things that people were asking when they saw that architecture was, does this thing run fast? I mean, does it run as fast on Windows? Which one should I choose to run on a faster environment? So here's what we did. The very first benchmark we released for TPCH, which is an analytic workload benchmark, was SQL Server on Linux. The second one we released last November was the number 1 terabyte benchmark for TPCH on Linux at the best price performance. And so the point is that it's not going to necessarily be faster on Windows or Linux. In some workloads, it might be faster on Windows, some on Linux, depending on your hardware or how you configure the operating systems, right? SQL Server itself should run equivalent with equivalent hardware and equivalent configuration. But we wanted to show the world that we're very serious about performance because it's one of the bedlams of what we do in SQL Server. But we're also serious about price performance because we really do believe we have this price performance database platform on the market today. So that's one of the things we did out of the gate is to show TPCH running in a very fast way. We didn't do any special bells and whistles. This is just SQL Server configured to run on a Linux environment. And so just to make sure you know, because I've had this question, is it faster on one or the other? It should be equivalent. Some workloads faster, depending, again, on your hardware and your operating system configuration. But think about technologies like column store and in-memory TP. Again, it's the same core engine. Remember my architecture diagram, that gray box called SQL Server? That's the same code we built for both. So column store and in-memory TP run the same in that technology, and they're still available to you. Remember I talked about adaptive query processing and automatic tuning for keeping you fast, not just building a fast application, for keeping you fast. Those technologies fully available to you to run on both platforms. And then again, take a look at our best practice guidance. I've had some folks that are Linux experts that say, hey, how do you tune this kernel parameter to run for SQL Server? And if you go look at our best practice guidance, we focused on the ones we thought were most important to ensure that we perform well for CPU, I/O, and memory for running a Linux system. So take a look at those guidance as well. And if you don't believe me that it's just me saying all this stuff, our benchmarks, we do have some customers that have actually done this, and DV01 is one of them. And there's a customer testimonial for them that you can read. And it's not just a marketing pitch. DV01's an interesting customer that was a Postgres shop, loves Linux, and they were kind of not seeing the scalability they needed from Postgres. And so they contacted us and said, look, I heard about the SQL Linux thing. What is this like? And so we worked with them through all the community technology previews to help them migrate their application. And now they run a very scalable app running SQL Server and Linux in their environment. And Column Store was one of the key technologies that allowed them to achieve high scalability for analytic queries. If you think about SQL Server or any data platform, performance is one of the huge features that anybody has to have. But if you don't have a secure database and secure data, performance doesn't matter much, right? And so all of the features that you know and like and love about SQL Server security, we've got them for SQL Server on Linux. In some cases like TLS to get encryption in transit, there's some special configurations you have to do on the Linux side, different than you might do on Windows. But, technologies like always encrypted, transparent data encryption, row-level security, dynamic data masking, auditing, they all work on SQL Server on Linux because, again, it's the same core engine. And this chart on the right-hand side over here is not something we made up. This is done for an independent organization called NIST that demonstrates that over the last 7 years, SQL is the most trusted platform from a security vulnerability point of view, and we're kind of hands down towards any of our competitors. And then also, again, if you think about these feature sets, this is defense in depth type technology to give you, protection across all sorts of layers of information, access management, and even threat protection. And what's not on this slide that's brand new is our tool set through things like Management Studio now offer information classification and vulnerability assessments for things coming up for GDPR compliance. So if you're a customer on the phone right now, or if you have clients that are concerned about GDPR, we've embraced that with SQL Server, and we have new tools for you to go look at. You can just search for SQL Server GDPR through your favorite search engine and find these new tools we've built to help customers move towards that GDPR compliance. So I mentioned before also that connecting to SQL Server, you can do it with SQL authentication through standard SQL accounts, or you can do something called Active Directory authentication. And so it requires some setup and configuration, maybe different than you would do on Windows, for some Linux specifics, like using a package called Realm to join a domain. But that's really the concept here. Look at these steps. You'll take steps on Linux to join a SQL Server host to an Active Directory domain. In your Active Directory, you're going to create a user for SQL Server and a service principal name. Then you're going to configure something called KeyTab on Linux. And then it's all SQL-based at this point, right? You're going to create new logins through Transact SQL for your Active Directory users, and then you start connecting. And all of our tools and your application have mechanisms to say, hey, I'm an Active Directory user, this is my Active Directory credentials, connect into my server, and go from there. So that's really the steps in the process to do it. And all of our tools, again, support using that once you make this configuration. So performance and security, right? Bread and butter type things that any data platform has to have, and we think we've got best in class. But the next pillar would be high availability. In many cases in your environment for mission critical scenarios, you have to have high availability. And so in SQL Server on Linux, we have great choices for you. So think about these areas: failover cluster instance, which is shared storage based, a highly available availability group, and something called a read scale availability group. Let's talk about each of these. So in Windows, you're used to setting up a Windows Server failover cluster with SQL Server and availability groups for failover cluster instance scenarios to get that shared storage scenario. And that's still applicable to many customers. That's what they want. They just want to do a shared storage scenario. They don't want to do availability groups, right? And so we support that using packages called Pacemaker and CoroSync. You would set up a single SQL Server instance. Remember, we don't support multi-instance. And then you would pick the favorite shared storage mechanisms that you like to use. And then we have something called a SQL Resource Agent, which is a package you install and enable that helps coordinate all of this. So once you go through these steps, which are fairly Linux specific, SQL Server will behave now very much like it does in Windows to do failover clustering. The other scenario you might pick, though, is something called an availability group, because you don't want a shared storage solution. And so we have something now called a cluster type equals external through the Transact SQL language. And these are scenarios that you want auto failover capabilities. You've got an availability group, you've got a secondary replica, you do sync replica, for example, and you'd like an auto failover scenario to work, and we support that. And so you get full AG capabilities in these scenarios. But the third one is new to SQL 17, both for Windows and on Linux, and that is a cluster type equals none. So we determined that our availability group software, all the infrastructure exists to ship log blocks to secondaries, and as long as you don't want auto failover, we don't need any clustering software to make that part happen. And so we offer that as an option now. If you've got secondaries, think about a read scenario. You've got 8 or 9 replicas out there. You'd like to set up a SQL server to use availability groups to pump data to those replicas, and then you're going to point your readers all to those replicas in a scale-out, round-robin, loaded fashion. That's what you'd like to do. Well, we support that now. And if you did want to fail over actually one of those, you could do it manually. So you could have your own process set up to actually make that happen. So if you don't like setting up clustering software for availability groups, you now have this option. Again, it's not auto failover automatically. You have that manual decision to make. But it is a nice option. And by the way, one of the things that this now allows you to do is to do this cross-platform. So imagine this scenario now to where you've got a SQL Server on Windows and you're actually going to migrate to SQL Server on Linux. That's your plan. But it's going to take some time. So what you can do is you could start up a secondary on Linux with SQL Server and your primary on Windows, start doing an availability group between them, and then at some point when you feel like you're synchronized, you're ready to go, you can just switch over to a live migration to the SQL Server on Linux environment. So it's pretty cool. And you have other scenarios like distributed availability groups to make this even a more robust scenario. All right, let me go to the next slide here. So I don't have time today to show this, but there is a demo in the GitHub you can set up yourself with the instructions to do a cross-platform availability group between a Windows server and a Linux server. It's all T-SQL based, and it uses certificates to actually make the security happen between the two environments. Let me stop, Sarah, and see again. I talked about performance, the capabilities of SQL Server. I mentioned about security capabilities and features. And I mentioned about high availability features. Let's stop before we talk about containers in the remaining time we have today to see if there are any questions.
We didn't really get any questions on that. We did have some folks that joined in a little later, and they just wanted to reiterate and reaffirm, is there really no learning curve? Is the behavior and the way, like somebody that was been working with SQL Server on Windows now wants to work on Linux? Is there no learning curve? Is it like straight up just SQL?
Yeah, it's a great question. So I would say for the core database engine features, if that's all you're doing, let's say you're just doing column store indexes, or you're doing query processing, or building stored procedures, and so forth, that's the same. I mean, you can even use the same tools you're used to, like Management Studio, for example, right? Where you're going to start needing to do some learning is for things that are configuration-based. I just talked about high availability with availability groups. Configuring that in Linux is going to require some Linux knowledge. There's going to have to also be some base fundamental Linux knowledge to just traverse the shell to find files, for example. If you just want to go find files in your Linux environment, you're probably going to need that. Now, what's interesting, though, is some people probably have written graphical programs to allow you to actually do that in a GUI way, right? Most Linux people I talk to are very command line driven. They don't even use a shell. So they're used to traversing directories and things in a shell environment. And then the final comment I would make is if you want SQL Server to be optimized for performance, you're going to have to pick up some Linux knowledge to learn how to actually tune it that way. But depending on your distribution, like say you pick Red Hat, they've got some great documentation that couples with ours to show you how to do some of those steps. So I would say that in general and in summary, that just like you've learned certain things on Windows to make SQL Server run best there, equivalently, you're going to start learning a few things on Linux to make it run best there. But if you're just playing out of the gate, I just want to install SQL Server on Linux, and you can follow the steps we just show you in the docs, and I just want to start running queries against it, there's not a lot of Linux knowledge to make that happen.
Awesome. Thank you, Bob. One last thing they brought up right now was the documentation. So you mentioned, so should they be going to our documentation, or should they just go straight to Red Hat? So that's the sort of thing.
Sure. So I would start with our documentation. If you're just getting up and running and doing some testing on SQL, we've got all the documentation you need to get that going. If you're going to actually build a production bare metal server on say, Red Hat, you need to use the Red Hat documentation on how to do that, right? To install the operating system. Like if you're installing Linux from itself, because you have to have Linux installed, right? When you install Linux, you need to be looking at the distribution documentation to install the operating system. But, for example, let's say you just want to get up and running very quickly. You could use Azure Virtual Machine with one of our predefined templates where we already install Red Hat or Ubuntu or SUSE with SQL already for you. And then you start using it, right? But if you're going to do a VM, like I did a VM on mine, right? Or you're going to do a bare metal machine, you're going to need to look at the distribution docs on how to just deploy and get Linux installed, right? And configure it. Maybe you need to add a drive, like a separate drive, SSD drive for your data. You're going to need, again, you have to look up your documentation from your distribution to see how do you actually go add a drive. So, the advice is if you're just going to get up and running pretty quickly, and you say you've got a VM where Linux is already running, you're not going to need to go to their docs. But then you start actually installing Linux and then configuring it, adding drives, those kind of things, you're going to need to go to their documentation to see best how to do that.
All right. That's all we got for now. Thank you, Bob.
Great. So Docker containers. Think about a decade ago. For those of you on the phone in this industry a decade ago. At that time, a decade ago, was everybody saying virtual machines is it? I mean, people were kind of questioning whether, especially like SQL, like, should I run SQL in virtual machines or not? Maybe it's a little more than a decade ago. And so back then, who would have thought that virtual machines would be as popular as they are today? SQL Server running in virtualization is a very popular workload, even for production workloads for customers. I want you to start thinking of containers in that same light, that here's a new paradigm. It's not virtualization, and the reason it's not is because it's far more lightweight than a VM, using shared operating resources. And Docker is the most popular platform to deploy containers, run containers, and manage them. And so we fully embrace that, the Docker container environment. So think of containers this way. First of all, there's an image which contains all the operating system components for whatever operating system's in the container, the application, in this case it could be SQL Server, all the files, the binaries, anything you need to run just your container. But the key thing is, a lot of times these containers have just the minimal set of things you need. That's why they're more lightweight. So the image is what you pull down to run something, and that's like stored on your machine. The container is a running instance of that. And so when you run a container, we take the image and you start up this thing, and Docker is the engine that makes that happen. And Docker's cross-platform. So Docker, that's what I love about this, Docker runs on Windows, Mac OS, and Linux. Imagine these three scenarios down at the bottom. Like, why would I even do a container, Bob? I'm using just a virtual machine, right? Well, number one, remember I just told you on the phone here about installing Linux? Well, if you don't even want to mess with that, just use a container. Install Docker, pull down the image, run the container, and then imagine a world where you don't care about the operating system running in the container. Like, what if you could get to a world where SQL Server just runs as a database container, and you could really, really care less about what the operating system is anymore? I realize we may not be there yet, but that's the world I think we're heading, and that's the promise of containers. Maybe in your environment, your customers or you are interested in DevOps and this concept called CI/CD, continuous integration and continuous deployment, a really new, bright and shiny thing that a lot of development shops are looking at. And containers allow you to do that, and SQL fully embraces that. So again, imagine a world where you today maybe have a database server with SQL Server that's a shared server, and you have these conflicts all the time where devs are stepping on each other. Containers allow you to create SQL Server and a subset of the database itself. It could be a subset of your production or test data some way, and each developer has a consistent view of the SQL Server that everybody's going to use, but they don't step. Their containers gives you that promise, and a new way to accelerate pipelines to move and get that continuous stream going of your application with SQL Server itself into production. And then we talked about HADR for failover cluster instance or availability groups, but the most popular orchestration software for containers out there is called Kubernetes. And Kubernetes offers a way to manage a lot of different containers and provide an HA environment built in, and I'll show you a slide on that in a second. So how do you do this? So in a matter of minutes, if you install Docker Engine, let's say I install Docker Engine for my laptop for Windows, I can do something called a Docker pull. These are actual Linux examples, Linux bash shell examples, but they work similar in PowerShell. And we have those examples for you in our documentation. But basically, you do a Docker pull, and then this is the name right here of our latest Docker image. Now, our Docker Hub image is based on Ubuntu, and it uses SQL Server Developer Edition. I'm going to show you in a second, like, how would you do this in production with a paid version of SQL. So you will do this, and then look what you can do here. You can do a Docker run and provide it parameters to specify your password, your EULA agreement, your port mapping. If you're going to run multiple SQL servers in Docker, you can't have this port for TCP conflict, so you need to map a different port number than that one. So you will end up connecting to port 1401 instead of the standard one to do this, and then you can name it. And then you say, hey, this is the image I want to use, and now all of a sudden you're running, and now you can start connecting. You can actually do this is an example of doing a Docker command where we actually run a bash shell into the Docker container, and you start interacting with the shell as though you were inside the container, almost like a secured shell type thing. Or you can use your popular tool that you'd like to remotely connect into the container, even if you were just on the same physical machine. And then you just start working with SQL just like it is anything. And let me stop for mentioning to you about licensing. Because people ask me that all the time, like, hey, okay, so how do you license SQL Server in Docker or SQL on Linux? If you have a contract with Microsoft and you have a license for SQL Server 2017, that license works for Windows or Linux unchanged, and it also works for Docker unchanged. Now, we also have some special licensing offers, and you can look at these on our documentation pages. If you just run one SQL Server on Linux, we have a new subscription offer for you that you can use, and you can get discounted rates for things like Red Hat and SQL together. So licensing works the same, but there are also some special licensing offers if you're just going to do SQL Server on Linux. So here's how to do a production Docker container. You would actually run Docker, but you'd be able to specify the PID, like enterprise here. And then we would actually burn in and say, okay, well, we're going to start running this container, and it's not going to just be a developer edition, it's going to be enterprise edition. You would use something called the Docker store to actually pull down the image in this case. And then here's an example of running multiple containers on the same machine. And the key is these port mappings. So it's two SQL servers that are going to be running on the machine because Docker is going to manage these containers separately, and they're isolated. They're different, but the ports will be different here. So you would connect to the given port number depending on which one SQL server you wanted to connect to. And then Docker always allows you to pull with us a specific version. Like, do I want to pull down CU2, cumulative update 2, or 3, or 5, or the latest one, or whatever I'd like to do. And then, here's just some comments about we support availability groups. There's a separate Docker image out there for the tooling if you just want to run a tooling package container to connect to other SQL servers. And then the hub image that we've got built up there contains just the engine, but it has the tools also baked into it. So when you run a container, a Docker container, you can actually add data to the container, like a database. You can restore a database. And you can start and stop that container just like you would start and stop a VM. It's much more lighter weight than doing that. And that persistence of what you've added will be retained. But if you remove the container, which you can do, like you delete it, then you lose any data you put into it. So Docker offers this option where you can map an actual permanent storage of your location somewhere on your network, and you map that into a local directory in the container. So now when you reference var opt MSQL, you're really going to be referencing, say, a remote storage that's persistent. So when the Docker container is removed, say your database, it actually is saved. So that's a way some people are doing when they actually want to share a database. The problem is with doing this from a multiple container scenario is that host data location is locked by Docker. So you don't have multiple containers that accesses. It'll be one container at a time doing it. But it is a way to do data persistence. And then finally, we talked about Kubernetes as an orchestration environment. And that name and term may be new to you. If you're in the Linux world, you've probably heard of it before. And it offers new ways of orchestrating maybe hundreds of SQL Server containers and providing a natural high availability environment. And here's how it works. So in this diagram right here, Kubernetes offers something called nodes and pods. So think of nodes as like a host, and a pod is something that's going to host a SQL Server container. So what could happen here is if that the container itself in these pod fails, Kubernetes can detect that and automatically start up a new pod with a new container. So again, think of it as an HA thing, and it uses a persistent volume that's shared to do this. So it's just very much like a failover cluster scenario, but you're not using failover clustering software like Pacemaker or Windows failover clustering to do this, right? So that's one scenario you have with Kubernetes, and you configure all of this when you work with your Kubernetes environment. And one of the ways that we show customers how to do this is with Azure Container Service. We've got documentation to use that as a Kubernetes hosting environment. But any host environment that supports Kubernetes, you can do this with. So then you may think to yourself, okay, what if the node fails? So if Kubernetes detects that the node is failing, it will actually start up a new container with a new pod on a different node. So it supports both failover, high availability type scenarios, and this is a common way to do shared storage. And so the app has the same concept like you do in maybe a failover clustering environment of a similar IP address to use to connect no matter where the container itself is running. So today we support this with shared storage, and we're looking in the future like how could we actually set up availability groups to work in the same type environment. You've heard me talk about tools. I showed you Operations Studio, and so one of the things that we're a big believer in is ensuring that our current tools like Management Studio on Windows or SQL Server Data Tool on Windows work really well with SQL Server on Linux. But we've got new paradigms and new environments. We've taken the command line tools like SQL Command and BCP that you saw here, and we've compiled those natively to run on Linux, and we've got a preview for actually to run on Mac as well. Third-party tools that know how to connect to SQL Server should run unchanged. They should continue to work. If they've got some dependencies that are operating system specific, maybe they've got some issues. But for the most part, we've seen from our partners, maybe it's, for example, like our monitoring partners, like Redgate and SentryOne and SolarWinds and Idera, all those tools can work against SQL Server on Linux. We also embrace Visual Studio Code, which is a cross-platform open source environment for developers. We've built an MS SQL extension that works now, and so that's a possible scenario if you're a developer out there and you don't run Windows, but you want to develop against SQL and Linux, you can use Visual Studio Code, say on your Mac, and you can connect it with MS SQL extension. And then SQL Operations Studio and MS SQL CLI are two new tools that we are offering, both cross-platform and open source. And you're going to see, and here's some examples of some other command line tools that I mentioned that we do, like MS SQL Scripter or DBFS, which allows you to actually look at DMV data as though it's a file system, and then MS SQL CLI. This is the new direction for tooling at Microsoft. We continue to support and enhance Management Studio on Windows, but that's going to remain on Windows. New tooling and new tools we built, I think you're going to see from us this direction of making them cross-platform and open source. So before I do a demo, I just want to tell you one thing if you're listening on the phone, and this is something you can talk to your customers about. I was at a recent event talking about SQL Server on Linux and Docker containers, and a customer raised their hand and said, look, I'm not a Windows user. I'm a Mac user. I'm a Linux user, and I don't even want to run Windows anymore. I mean, I don't want to touch that. I don't want to run a virtual machine, and I don't want to install something separate, like have to connect to a SQL Server on Windows somewhere in my environment. What do I do? And I said, I got you covered. In fact, I challenged this person to get on Twitter and say this. I said, I want you to go back to your office this week on your MacBook. I want you to download Docker Engine for Mac. There's a native Docker Engine for Mac. Download that to your MacBook. And then I want you to do a Docker pull of the SQL Server image in that environment. And then I want you to install SQL Server Operations Studio for Mac. And I want to see if you can do that in 10 minutes. Like in 10 minutes, can you do all of that and be up and running and connecting? And he got on Twitter and he said he did it in 5 minutes. So, that's the power of what we're offering now as a platform of choice. You have now a new world of users that are used to Microsoft saying it has to be Windows. And we love Windows. And you see I'm running on Windows today, right? But if you've got other platforms and other hardware machines that you like to use that is not Windows, SQL Server fully embraces that environment. So let's just do a quick look here at Docker containers. This is a PowerShell window I've got running here. And I'm going to just show you this all command line right now. So Docker for Windows is running on here. And I've already done a Docker pull because that takes a few minutes to pull it down. So if I just do a Docker images here, I can see what images I pull down. So you can see I've pulled down the latest SQL Server for Linux Docker image. So I've got some command shell scripts to run. Like one of these is called Docker run.cmd. Now I'm running the Docker run with the parameters I showed you in that slide earlier. Here I'm doing the port mapping. And I'm going to call this SQL1. So this is what it looks like. So here's Docker run.cmd. Now what I could do at this point is I could just interact directly with the bash shell for this Docker. So if you look here at Docker bash, this is actually going to do a Docker exec. And Docker exec, what it does is effectively inject a program to run. It says, hey, go run this program in the container, but give me an interface to it. And that's what the IT option is. So I'm going to say Docker bash, .cmd. Now I'm running with a bash shell inside the container effectively. It's almost like a secured shell, right? So I can do something like this. I can say like opt MS SQL tools, because we install the SQL command in here, bin SQL command -usa, and put in my password, because that's what I specified when I ran the container. And I can run add version, and boom, you can see I'm connected to SQL Server. But look at this. I can also inject in a command that's not interactive. So here is, let me just make sure I've got this So here's Docker copy, my little program for you. This is going to copy a file, which is the wide world importer's backup from my local machine into the container itself. So Docker copy.cmd. And then I'm actually going to run SQL command as a Docker remote command. So if you look at Docker, restore wi.cmd, this is me taking Docker exec and running the SQL command in the container to actually restore the database I copied in there. So let's just do restore wi.cmd. Now you could have done this remotely. I could have done SQL command here. I could have used Management Studio at this point, Operations Studio. I can use all the tools that connect to SQL just like they're running on a virtual machine or environmental machine. But I'm actually interacting with the Docker container, and this exec command almost lets me do it remotely. Like run a command for me and just come back and tell me when it's done. And remember, how about containers here? I'm actually installing and restoring the database in the container, but on its local drives as it sees it. This is not a shared persistent volume like I talked about data persistence. So when I stop the container and restart it, the database will still be there. And so now I could go in and I could just interact with this database, right? But if I remove the container, then it'll be gone. I would need to use a shared volume. And that's as easy as it gets to actually interact with this thing. But again, any common tool that I have, SQL command, MS SQL CLI I told you about, Management Studio, Operations Studio, if you just connect into that port 1401 as I established, you can now interact with SQL Server just like it was on a bare metal machine or in a virtual machine. And that's kind of how easy it is to kind of start playing with Docker. And again, these kind of type commands is what you do on your MacBook, for example, to interact SQL Server, and there would be no Windows virtualization software required on your actual Mac. Wow, Sarah, that's pretty cool stuff. What do you think?
It's amazing. And I'm
any questions from the audience about it?
No, not at the moment.
They're probably sitting back going, now, how did he do that again? How does that Docker stuff work?
Most likely.
Yeah, honestly, if you're out there listening today and you want to quickly get up to speed with SQL Server on Linux, Docker is the way to go, because you don't notice I installed no Linux software at this point. The container contains already the installed operating system. You could use Azure Virtual Machine with the templates we provide, but if you're going to do this just on your laptop, for example, and you just want to interact with SQL Server on Linux in a quick way, then Docker is certainly an easy, lightweight way to do that. I thought I'd also tell you another customer story real quick here. I know we're just a little bit over time, but if it's okay with you, Sarah, I'll go over a few minutes. Is that okay?
You're perfectly fine.
Awesome. Thank you. So we had this company called Convergent that talked to us. They were a shop that was completely SQL Server on Windows, but they had part of their company running on Linux, and that could be common to those of you on the phone listening today. So you may be saying, like, okay, well, what do I do? Well, did you just see the restore example I did? That backup was a backup that was made on SQL and Windows. So what this company did in a very simple way, because they didn't require a live migration, they took a certain percentage of their machines running SQL Server on Windows, and they were able to copy and restore their backups to running on Linux. And for them, it actually saved them money and time, because for them, the Linux environment that they needed to run some of their applications was just a better platform for them than Windows. But they're still running Windows. So I think you're going to see this as a little common scenario for customers now, is that they have this choice, and for portions of their organization that were kind of the Linux folks, like I don't want to talk to those guys, those are the Linux folks, right? And you get the SQL folks that are used to Windows, now they can start having conversations. And I've had conversations recently with many customers that are having this discussion. Hey, we've got Linux in our environment. Maybe we should be using that for some of our SQL apps. And we're talking about anything from lightweight applications to big scale, high-performant SQL apps. So let me just conclude here a little bit and talk about where we're headed next. In the SQL team, we kind of operate like the cloud. We operate very quickly. You've noticed we've released SQL 2016 and 17 in consecutive years. I'm not here to tell you a date. I'm not here to tell you a feature set. We haven't made all those decisions. But as soon as we release SQL 17, in fact, before we released SQL 17, part of our team was already thinking about what do we do for the next release of SQL Server. And see, these are some of the themes that we're thinking about. We're not sure if we're going to do all these things, but you have to always start with a plan, like what do you want to go do? And if you look at the top here, big data is one of those areas. So you may have seen this feature called Polybase, which doesn't work with SQL Linux today, but works on Windows. We'd like to make that work on Linux, but we'd like to go bigger here. It's our desire to not just do what we did with Polybase, but to literally embrace the big data ecosystem and kind of combine it together with the power of the SQL relational engine in a new and exciting way. If you're on the phone today and that's something that highly interests you, I'd love for you to contact me directly, and I can put you in touch with our team that's thinking about this new way of embracing Hadoop ecosystems and big data with SQL Server. We want to continue to build on the choice of language and platform. We want to kind of nail down more scenarios on containers. We want to support other new platforms out there. Right now, we just pull from Docker Hub, but for example, Red Hat has their own container catalog. You can already do Red Hat on their OpenShift platform today, but we want to make sure we really bake that in and make it a great experience as well. We talked about machine learning services with R and Python and native scoring. And I didn't get into those technologies today, but unfortunately machine learning services for R and Python don't work with SQL Server on Linux in 17, but native scoring does because it's in the core engine. But we'd like to make that work for Linux, and we'd even like to look at possibly other external scripting languages that we could put into that platform that we've done the same with R and Python. We're going to continue to make SQL Server the best performing database on the planet. I believe that very heavily that we are, and the best price performance database on the planet. And so we'll continue to make sure that with each release we make SQL Server faster and better. Sometimes it's new features that we do, but often cases just us tuning the engine in a new way based on customer experiences. We're going to double down on that adaptive query processing type technology and make that even better with new scenarios. And then I mentioned some tools for GDPR compliance we have today. And remember, those tools work for SQL and Windows or on Linux or even for Azure. And so take a look at that tool set, and we're going to try to keep giving customers the tools they need to ensure that they're complying with GDPR policies. And then I mentioned about machine learning services, and then some of the feature gaps I talked about. distributed transactions, transactional replication. We'd like to look and see whether we should support new login types. You know, Linux, I was logging in as a super user and another user that I had on my machine. You know, is there a way somehow we could actually allow authentication for local Linux users versus Active Directory or SQL logins? And then finally, SQL Agent does support T-SQL jobs on Linux as it does in Windows, but it doesn't support a command type job as it does in Windows. So we're thinking about, well, what's the right thing to do there? And I don't think Windows command shell jobs make sense in a Linux environment. Why not do something like Bash? So maybe give you the ability to do like a Bash script and schedule it through SQL Agent, and you combine that with your other T-SQL type jobs. So those are just some of the thoughts we have. There's other things we're also thinking about, but I wanted you to walk away and make sure you understand that this is a huge investment for Microsoft. We didn't just throw out SQL Server on Linux and say, hey, there's a checklist. Microsoft has SQL Linux now. No, we're really serious about making this a future investment with us and investing both on the Linux and Windows platform. Here's some resources for you to take a look at. Remember, AKMS Bobword MS, that the deck you just saw is out there right now, and other decks that I do in other presentations. And if you just look for GitHub Bob SQL from your favorite search engine, you will find the demos I did today are out there available to you. So take a look at SQL on Linux, give it a spin. Take a look at SQL Server on Docker Container, give it a spin. And, I'd love to hear your feedback on it. Is it as easy as I just said, just to get up and running on the platform? So, Sarah, thanks so much for having me today.
No, thank you, Bob. That was fantastic. Folks, if there are any more questions, please post them on the AM window. Otherwise, if you have questions later or after this call, then reach out to us on Yammer or reach out directly to Bob. It seems like he's very happy with that.
Yeah, I love talking about this stuff. It's kind of strange. People think I'm kind of weird that I want to talk about this at all hours and all times, but I do actually.
Well, I'm glad you do. That's how we got you here.
Yeah.
All right. For those of you that joined late, do make sure to check out the recording. You can access that after the call on the registration page. We'll also have it accessible on the Yammer group as well as the MPN YouTube page, the Microsoft Partner Network YouTube page. Apart from that, let me just check if we have any questions at the moment. And it doesn't seem like we do. So before we let you go, folks, let me just show you a couple stuff.
Hey, let me stop sharing it. You mean stop sharing, Sarah, so you can show them?
Yes, please.
Yeah, absolutely.
All right, thank you. And let's see. Let's give the presentation a second. Let me know if you can see it.
Yeah, I can see it.
All right, awesome. So we are running over, so just giving you guys a quick reminder of a few things. We do have a few announcements. Service Fabric is now open source. That's exciting. I don't hear excitement. Bob, you should be excited about this.
I am very excited because we're taking a look at how to run SQL on Service Fabric. So yeah, I'm excited.
Yes. Channel 9, we have a show dedicated to open source, and there's Data and I training series that's going to have Cosmos and Postgres training, all this amazing stuff. We have made those announcements on our Yammer group, so you might be aware of this if you're active on that group, but if not, these links are here. You'll have the deck. You'll be able to find out. And I'm just going to run through this since we're running over. This slide, you always see this slide. You might be tired of this slide. You see it every month. But these are all the resources you have as a partner. Not just limited to open source, but all the other solution areas and just the partner network overall. Please keep that in mind. Remember, we have the 4 solution area communities apart from the open source community. They hold their own call every month. And these are the times. You may notice Mother Workplace has 3 different calls. That's just because of the amount of topics and products that they cover. So if you're interested in any of those, please do check them out. Lastly, this is our OSS group, the blog, the call, the Yammer group. You all know this, I know, but we got to put it out there for the newbies. And lastly, not lastly, I keep saying lastly, sorry about that, folks. Open source at Microsoft, big spectrum. You have the blog, the openness blog, you have Microsoft open source with Azure, like all the relevant information regarding Azure and open source, and just the Microsoft Partner Network open source. Now here, what I want to highlight is the open source meetups with the Global Black Belts. If you haven't gotten involved with that, make sure you sign up. Those are amazing meetups on Fridays. You get access to the people that know their stuff, the Global Black Belts. What better connection to have? And now, yes, finally the last slide, and then I'll let you go. Join us at Microsoft Inspired. If you haven't registered yet, register. July is coming up, folks. It's coming up soon, and you may want to book those flights already. But yeah, that's all we have for today, and we'll see you guys next month. Thanks again, Bob. You were
Thanks,
amazing.
Sarah. Enjoyed it.
All right, see you guys. Goodbye.
See you later. Bye-bye.